Don't forget to subscribe and turn on notification.
Okay guys, how are you doing? I hope you're doing well. Welcome to our YouTube channel. In this tutorial we are going to develop a machine learning model for predicting music preference, and then after we'll deploy it on Django. Before I give the introduction and overview picture of this project, I would like to apologize for those machine learning learners. I mean, those who subscribed in order to get the uh, daily updates about machine learning videos. I apologize. It's been a while I have not uploaded any content relating about machine learning. I was a bit busy with Django tutorial, but now I'm back on the track. So after apologizing for you machine learning fans, so I would like to give you an introduction of this project. Actually, this is Django machine learning tutorial, right? In this tutorial, we are going to create a model which predict the preference for music, personal preference for music, right? The model will take two input, which is age and gender. So according to your gender and according to your age, our created model will be able to predict which kind of music you prefer. You prefer hip hop, you prefer dance, you prefer classical and whatever, right? So that is, so after creating a model on machine learning, we will deploy it on Django. As you can see from the front view of your computer, this model is well developed by Django, which is a Python web framework, right? I hope that introduction is clear and well understood. So after introduction, I'll give you which steps will take us to have this final project, right? So our tutorial will have about 5 steps. Step number 1 will be loading of dataset, cleaning the data, which will involve dealing with duplicates, value, handling missing values, and data conversion, converting object data types to integer data types. Then after we train a model, after training a model, we'll test the model. Then the final part of this tutorial will be deploying a created model on Django. So those are the 5 steps, or those are the small subcategories in our long tutorial, right? After getting the introduction of this project, after getting the content to be learned in this video, now is demo time. Okay, open your eyes and clearly see how the project works. As here you can see, please submit correct information. Please submit your age and submit your gender, right? I've told you that you need to provide correct information because the data received from a form are not validated, right? So here I'll type in my age and I'll type in my gender, right? So I'm 24, right? 24 years old, and my gender is male. So once I click predict, you can see your preference music is hip hop, and this is true. If you don't know, I like Migos, I like Young Thug. In short, big time, I'm a big fan of hip hop, right? So here you can make several predictions. I can say I'm 8 years old, then my gender is female, which is not true. Then once I hit predict, you can see your preference music is dance. It's true. These children were ranging from 5 years old to 12. They like dancing music, right? So let me try to input another age. Let's say I'm 56, then my gender is female. Once I click predict, you can see your preference music is classical. So this is how beautiful our project will look like at the end of this tutorial. So never plan to skip, never slow down the motion, keep your vibe up, and let's learn this a brief tutorial. Guys, I hope you know how you can create a project on Jupyter Notebook. So in first phases of this tutorial, we are going to start dealing with Jupyter Notebook. Then after, we'll shift on dealing with PyCharm and Sublime Text when a time for deploying a model reaches, right? So here, as you can see, you can create a folder on your desktop named as a project if you want to go with me, right? So here, as you can see, the path where I am at Jupyter Notebook is desktop. So on desktop, I created a folder named as AI, which stands for artificial intelligence. Then after, I created a folder named as project, right? This is the folder. Then after, there is a folder named as music prediction. So if you want to go with me, on desktop, create a folder AI. Inside AI, create a project folder named as project. Then after, create a folder named as music prediction. So inside the music prediction, you can create a new Jupyter Notebook, right? Then I give it a name, music prediction. ML, machine learning, music prediction. Right? So after renaming your Jupyter Notebook, so here we begin with part number 1, and part number 1 of this tutorial is just loading of dataset on Jupyter Notebook. But before we load our dataset, we need to import necessary libraries to be used in this project, right? So the first cell of our Jupyter Notebook is for importing necessary libraries. So here I comment and I write import libraries. So I import numpy as np, then import pandas as pd, from pandas import read underscore csv, from pandas import read underscore csv. Then after, we need to import matplotlib if necessary. I think it might be used for plotting some beautiful graph. So import matplotlib .pyplot as plt. Then after, inline matplotlib to make sure no graph goes out of our Jupyter Notebook cell. Inline matplotlib right? Then I run this cell. You can click on run, or you can click Control Enter or Shift Enter. So import matplotlib okay, matplotlib inline, Control Enter, matplotlib So now everything is okay. We have imported our necessary libraries to be used in our project. So in a second cell, we are going to load our dataset. So here on the top of your Jupyter Notebook cell, write import or load dataset. Okay, before we load our dataset, let me show you a dataset folder, a dataset file. So here, as you can see, this music.csv is our dataset. You can see here there is gender, there is age, there is genre, right? So we need to load this file on Jupyter Notebook. So what we're going to do is we type a file name. File name is music.csv. Okay, then after data is equal to read underscore csv, read underscore csv. Then after we pass in a file name, right? After that we need to see first 10 rows of our data set. So data.head, head function usually display first 5 rows, but once you put like this 10, it will show first 10 rows, right? So okay, what I can do here, data.head lead csv. So here there is mistype of a dataset name, so it's music.csv. As here you can see how beautiful a loaded dataset look on Jupyter Notebook. Here you can see on the first column is age, second column is gender, and the last column is genre, right? So we are done with part number 1 of this tutorial, which is loading of data on Jupyter Notebook. But we can need, I think there is a need to seek or to get more information about our dataset. So we can type some few functions, like we want to know the data types of each column. So here what I can do is data.dtypes. Now you can see age is of type integer, gender is of type integer, but genre is type of object. We everybody know that machine learning usually deals with data which are of integer type. So there is a need for few coming minutes to convert this column genre from object to integer. But now we are aware of our data set according to data types. After that, I would like to know the shape. I want to know the rows and the column of our data set. So data.shape, I want to display the shape. So you can see we have about 18 rows and 3 columns, which is a very small data set. It's very small, and I think the disadvantage of having a small data set, right? When you train a system by using a small data set, you will get low accuracy. This is like when you're teaching a student. When you're teaching a student with very few examples, there is a great probability that your student won't understand. But as long as you're adding more examples, you're exposing a student to more examples, a student will have a great probability of understanding. So this is also same applies to machine learning. The longer the data set is, the greater the accuracy you get. The smaller the data set is, the smaller accuracy you get, right? So our data set is very small. After exploring the data types and the shape of our data set, I think nothing more. I can say this is end of part number 1 of this tutorial. In part number 2, we are going to clean our data set. We're going to handle duplicate vowels, we're going to handle missing vowels, and we're going to convert object to integer. We're going to convert the data types of column genre from object to integer, right? Never skip, stay with me. Guys, after part number 1 where we loaded our dataset, is part number 2 for cleaning our dataset, right? When dealing with cleaning of dataset, we'll look at 3 things. Number 1 is handling missing values, number 2 handling duplicate values, and number 3 is data types conversion, will convert object data type of column genre to integer, right? So let's begin with checking if our dataset have duplicate values. So in this cell I comment here handling duplicates. Okay, so I want to calculate the total number of duplicates present in our dataset, present in each of our columns. So data.duplicated bracket dot sum, then bracket. Once I click enter, you can see the total number of duplicates is 0, right? This means that none row is duplicated. So after checking that we don't have duplicate values, no need to handle them, no need to drop. But if we could have duplicate values, probably we would, not probably, it's strictly we would drop them, right? So far so nice, we don't have duplicate values. So we are done with number 1 method or way for handling for number 1 method for cleaning the dataset. Number 2 is we are going to check if we have missing values, and if we have missing values, we will delete every row which have a cell as missing values, right? So let's check. Here type comment, then handling missing values. So data dot is null, bracket dot sum. I want to calculate the sum, the total number of missing values in each of our columns. So I click enter. Now you can see on first column, which is age, we have 0. We have 0 missing values. On column gender we have 0 missing values, and on column genre we have 0 number of missing values. So as you can see, we don't have any duplicate values, so no need to handle. We don't have missing values, so no need to handle. But if we could have missing values, and if we could have duplicate values, a best option is to drop. You drop every row which have a cell as an A, which have a cell of missing data. And if we could have duplicate values, we could drop a value which duplicate to another. We leave original row, then we delete the rows which are duplicated to the original. I hope that's clear and you understand. So the last thing we are going to do is we are going to make a data type conversion. We are going to convert column genre from object data type to integer, and we are going to do this with the help of replace function of a data frame in pandas with a Python dictionary, right? So here I'm going to do something here. So before we convert column genre from object to integer, let's get a list of unique attributes of column genre. So here I can type data.genre .unique, then I click enter. You can see the unique attributes or the unique music is hip hop, jazz, classical dance, acoustic. Yeah, I hope there are 1 2 3 4 1 2 3 4 5. There are 5 unique music, right? So let's convert hip hop to 0, hip hop to 0, hip hop to 0, jazz to 1, classical to 3. Let's do it with the help of replace function in Python pandas and Python dictionary. So here what I can do is data.generate.replace data.generate.replace. Then here I create Python dictionary. So let me copy this. I like copying and pasting. I'm a big fan, I'm a big fan of copying and pasting. So here I just paste this. Then what I do here is I can say hip hop will stand for 0, jazz will stand for 1, classical will stand for 2, and dance will stand for 3, while acoustic will stand for 4, right? Then after here, impress true means accept the change, save and accept the change, then return a new data frame, right? So impress is equal to true, right? So once I click enter, everything is okay, right? So let me try out to display our data set to see if there is any changes have appeared. So head, then 10. I click enter, you can see here hip hop will stand for 0, 0 jazz. So now you can see our whole data set is now in of data type of integer. Let me type data.d types. We can see, and the machine learning, most of time machine learning deals with number, right? With exception of natural language processing, which extract some features from words. Yeah, it's about NLP, and yes, almost is NLP, and there are some tricks for dealing with a string in machine learning, like a count vectorizer, dict vectorizer, something like that. But most of the time machine learning deals with data type which are of type number, right? Let me show you something. Here there is a project named as YouTube comment prediction. So for this case, machine learning will deal with input as a string, then it will extract some important features from string, then convert inside into numbers, right? So for this case, like a comment, like predict if the email is spam or ham, comment, predict if YouTube comment is ham or spam, anything dealing with predicting words, it will take input as a string. So if you are doing a project which involve prediction of words, you can't convert word input into numbers, but for this case we just convert generally column from object to integer. And that is part number 2 of this video, which is cleaning the dataset. So far so nice. We are sure that our dataset is clean, and then the third part of this tutorial, I hope it is we're going to train the model, right? We're going to do train, test, split, then train the model. We'll do feature selection there between. I forgot to mention it. Before we train the model, we'll make a feature selection where we'll separate x's features and y's features, right? So the next part is about training the model, but before we train the model, we'll need to make feature selection. Okay, I hope it's clear. Part number 3 of this tutorial is to train the model, right? And we are going specifically to use decision tree as our chosen model due to high accuracy when I was preparing this content, right? Decision tree seems to be a model with high accuracy compared to multinomial naive Bayes and random forest. So before we train the model, we needed to make something called feature selection. We want to separate between X's features, which are the input to the model, and the Y features, which are the result to the model. I hope it's clear. So let's go. Here I'll put comment that this is feature selection. Feature selection. Then after, let me load something like this. Okay. After that, I needed to specify X train, X test, Y train, Y test is equal to train test split train test split. Oh guys, forgive me, I was trying to start with this is train the model. Let's say, okay, let me do something here. Let me cut this comment, excuse me, then I paste it here. Okay, I want to separate dfx and dfy. I mean, I want to separate x's features and y's features, right? So this would mean, right, then x feature is age, then gender. These are our input to the model, right? Y feature, which is the answer to the model, is data genre. I hope this is okay. I click enter. So after that, let me see. I want to display dfx feature. Now you can see this is we have successfully separated, or we have successfully stored column age and gender to df underscore x. So let me copy this, then add the cell below, dfy. Now you can see we have successfully made a feature selection. After feature selection, you are going to have train test split. We are going to separate our train dataset and the test dataset. Then after we'll fit the model, right? So here what we can do here is df x df y, then test size is equal to test size. I want to put 0.3, which means is 30% of the whole data set. Then after random state, this means it's just how randomly you want your train test split function to split your data set. So you can put 42, you can put 0, but most of machine learning engineers use 42, right? So after that, let me run this cell. Okay, here I can say train test split. train test split. We split a training dataset and test dataset. So let me learn this cell. I hope everything is clear. Here you can try something. Right, so this is X train. You can try to view X test. You can try to view X test. You can try to view Y train, right? You can do whatever you want. Y train is not defined. X train is Y train. You could, in short, you can do whatever you want. You can try to see Y test. So all of these data like X train, X test, Y train, Y test are created with the help of function, machine learning function named as train test split. I hope you're okay. I hope you get the clear picture of machine learning. So after that, we needed to train the model. We needed to fit the model. So here I can put comment that fit the model. Fit the model. Right, what I can, as I told you before, that I'm going to use decision tree. So before I'm going to use it, let me import it from sklearn.tree where it belongs. Import decision tree classifier. Decision tree classifier. After that, let me put, I want to store the instance of decision tree into a variable named as CLF, which stands for classification. So here I can do, let me try, it's okay. So it's a time now to fit the model, right? I can say dot fit, then I put X train and the X test. X train is X train, Y train, Y train. Then I click enter. Okay, after that, let me try to check the score. Here I can see, let me do something, print blah blah. Here I can print the score is below the score of the model. Below is the score of the model. Then I click enter. Okay. Okay, score need the X test and the Y test. Now you can see the score is 100%. 1.0 means the accuracy of the model is 100%, but I think we'll try to cross-validate the accuracy of the model so as we can be sure of our accuracy of the model we have got. We are able to see the accuracy of our model is 100%, but let's do one trick is called the cross-validation. You cross-validate n times. The meaning of cross-validating, so if you cross-validate your model by 3, which means that the cross-validation function, which is named cross-val score, will divide your dataset into 3 groups. Then it will train the model. Then at each category it has divided, it will output the accuracy for it. So cross-validation, cross-val score, it divides your dataset into several groups according to how you have defined it. Let's go on cross-validation to see, right? Cross-validation. So before I hope you understand the meaning of cross-validation. Here, as you can see, the accuracy is overfitting. When you get the accuracy of 100%, means you have the model is overfitted. So we want to cross-validate to be sure that if we cross-validate by 3 times, do we really get 100% accuracy, or the accuracy will be different? That is the purpose we cross-validate. Is like you validate, is this right, is this not, by doing it into small portions, right? Maybe if, how can I explain the concept of cross-validation? It's like maybe you are counting 100 shoes, right? So you are not so sure if these shoes, the sum or the total number of shoes is 100%. So you want to group those shoes into 10 groups, right? Means group 1 will have 10 shoes, group number 2 10 shoes, 3 up to 10 group. So after, then you validate one group after another. That would be a meaning of cross-validation in a few words. Let's go. So before we use cross-validation, let's import it from sklearn. So from sklearn dot model selection, from sklearn dot model selection, import cross-val score, right? Then v is equal to here I pass the name of classifier we're going to use. Then here is x train, then y train. After that, here cv is equal to 3. So for I in range bracket, then 3, which is cv, print the accuracy of decision tree is this is Python format, dot format, then bracket v I hope something like that. Let me learn this. Invalid for I in range, for I in range, for I in range, for I in range Now you can see the accuracy of decision tree. The first round is a 66, the second round is 100, the second round is 100. So our model is not overfitted, so the accuracy fluctuates from 60 to 100, right? So our model is, I can say, it qualifies to be used for making prediction. So here, let me do something. Print the average accuracy of decision tree. I copy the average accuracy of decision tree is v.mean. So you can see the average accuracy of decision tree is, the average is let me do format here, v.mean. Okay, what's wrong? Format, let me try this. Okay, but the average accuracy of decision tree is 88 percentage, right? As here you can see the average is 88 percentage. So we are done with part number 1, 2, 3. We are done with part number 3 of this tutorial, which is to train the model. But before we train the model, we had some few tasks, like separating our feature, our dataset into training. We did the feature selection to separate X's features and Y's features. Then after, we made a train test spread, which is machine learning function for separating training dataset and the test dataset. Then after, we fit the model. After fitting the model, we tried to check the score of the model, which was 100%. Then after, we made a cross validation of the accuracy of the model, which is by average 80%. So in part number 4 of this tutorial, we are going to test the model. But before we test the model, we'll dump the model in our disk by using joblib. Then after, load it, then make a prediction by testing a model. Guys, part number 4 of this tutorial is to test the model. I mean, we are going to make a prediction on Jupyter Notebook, but before we make prediction, we'll dump and load the model to the disk. Then after we make a prediction, we'll do all those with the aid of joblib, right? So here we are going to dump a model in a disk. So here I put comment, then I type dump the model. Before we dump the model, we need to import joblib. Import joblib as joblib. It's okay. Then after, what we need to do here is joblib.dump okay, then bracket, where I pass in is the name of a function, which I pass the name, which is CLF, which is presented by decision tree. Here, as you can see, CLF stands or carries the decision tree, right? Then after here, what is needed is I need to type, I can say, the path of where the model should be dumped. So, and the name is tree.pkl print model dumped to the disk. Then I need to load the model. Okay, let me copy this. Type model is equal to joblib.load. Okay, after loading a model, I can display the message that model is loaded. Model is loaded from the disk, right? So let me click Control Enter. What's wrong? The model is dumped, but the model is not loaded. Okay, model dumped to the disk is okay, but joblib.load, I hope it should be something like this. Joblib.load. Now you can see the model is loaded from the disk. So the last part, the last thing we can do in part number 4 of this tutorial is to test it, or to make it a real prediction, right? So here what I can do is I can say results. Here let me put comment, testing or making real prediction, or making real prediction, right? So here I can type results is equal to model.predict bracket, then here I path the age. My age is 40, my age is 24, and my gender is male. So one stand for male. I hope this is clear. Then after, let me print the result of the prediction. Results. Okay, I print. Now you can see the answer is 0. But what is 0? 0 is, if I come here on the section when we are doing data conversion, you can see 0 is equal to hip hop. So because I'm 24 years old and I'm a male, I like hip hop. Let's try to change the age and the gender. Let's say the age is 8, let's say 7, and the gender is 0, which is female. Let me click. You can see the result is 3. What 3 stands for? 3 stands for let me see 3 stands for dance. So if someone is having 7 years and is a female or a girl, she like dance music. So actually this is, I can say this is an end of phase number 1, where we are dealing with loading of dataset. We dealt with cleaning of dataset, where we tried to check if we have duplicate values, and we tried to check if we have missing values. Then we made data conversion of column generally from object to integer. We made the training of the model, but before training of the model, we made the feature selection there between. We made it train test split, then we trained the model. After training the model, we came to test the model, which was making a real prediction. But before making a real prediction, we dumped the model to the disk, loaded it by using joblib. Then after, we made a prediction. So the last part of this tutorial is to deploy the model, which is tree.pkl on Django. So forget about Jupyter Notebook. The last video is dealing with Python Sublime Text editor to do the codes so as we can deploy our model, right? Let me show you the dumped model in a disk. Here you can see tree.pkl is a model we have dumped in a disk. So get prepared, fire up your keyboard and wait for deploying of a model on Django. Guys, welcome to our last part of this tutorial, which is deploying a model, our machine learning model on Django, which is Python web framework, right? So before I do anything here, I need to give you a short summary of Django project. So long as I'm not going to create or to start a project from scratch, right? I have a Django project here, and the task of predicting it needs only one page. It does not need a big system, a big project. It just needs one page, which is for receiving input and displaying the output. So here I have already a Django project which is named ML. So if you want to create this Django project from the scratch, on a terminal type Django admin start project ML. Then after you will need to create an app named as comment by command Django admin start app comment. After that you need to open in ML, then open settings.py. In settings.py, make sure you register an app you have created, which is comment, right? Then after you need to link some CSS and a template folder, like this is template folder, this is a static folder. So this is for storing HTML pages, and this is for storing static files, which include CSS, JavaScript, and images, right? Then what else? You'll need to specify the database, which I'm using DB SQLite 3. Then here we put some, never mind, don't put model. You know, this project we are deploying just is an interface, so we don't give can say don't care about Django model, but these are the necessary things you can do, right? So let me close setting.py. Then after, what you need is open in app comment, open views, right? Then in views you need to import the following: import OSC sklearn. In short, import everything as I've imported here, with the exception of models and forms. Don't import models, don't import forms. I'm sure you don't have models bird, you don't have models on YouTube, you don't have form customer user creation form. So don't import forms, don't import models. The rest import all of them, right? So after that we need to create, let's create Django function for rendering our rendering our page. So here I'll create def home music, then request render returning render, right? Request, then comment, then home music.html. I control S to save the changes. Then I open in views, in URLs. Here I put home music, not to make a prediction, right? Home music, then control home music, Control S to save the changes. Then this is home underscore music.html, as you can see here, right? You can see how it looks like. So I'm going back on the browser. I'm going to refresh this page to see what's happening. Home music, refresh. Okay, so here it is, home music.html, right? So after that, let's create another function, Django view, which is special for making prediction. Forget about this, we'll comment this view soon after. So let me create Django function with the name make prediction. So def make a prediction. So this Django view will be performing two tasks. Number one is for rendering home underscore music.html, but the first functionality is to make a prediction of personal music's preference. So here I path request. Then here I specify if request.method is equal to post. Then do the following. Want to receive age from form. So request.post. I want to take age. Then I want to receive gender. So request.post. I path gender. Okay, path gender. Then after, what I want to do here is, first of all, I would like to convert gender from any type of character to lowercase. So gender is equal to gender.lower. So I convert, so it might be someone can type male or male in capital letter or male with mixing of capital letter and small letter. So to avoid that and go straight is to take the user input and convert it into lowercase. Then after, I would like to convert age from string to integer. We everybody know that if you receive any input from Django from HTML form, the type of input is a string. So we want to convert age from string to integer, right? Okay, so here I can type int, then I put a bracket age. So far you can see age is converted from string to integer. Then the next thing I want to assign, if gender is male, replace with 1. If gender is female, replace with 0, right? So here what I can do, I can say if gender is equal to male, then do this, gender should be equals to 1. Then also gender should be equal to 0. So this might be a female. Gender is equal to 0. So gender is equal to 0. So far so nice. I hope you are with me and no one is lagging behind, right? I'm sure no one is lagging behind, and I can't slow down the process. Let's go on running, right? The next thing we need to do here is, first of all, I can say let's load our model. I would like to copy this. So here what we do is we want to load the model. So os.path.join, we want to load the model named as a forest, which is dump the random this is, I want decision tree. I want tree, not forest. This was model, this was random forest. I want tree. So what we do here is to load decision tree, dump the model. After loading, let me take my data set for making prediction. Then I pass age and gender. Then what else? I need to change the shape of array, right? So it can be supported by model when making prediction. It needs array of 1 comma negative 1 shape. So what we can do here is numpy.array, then bracket data. Okay, then reshape. We want to reshape, change the shape of our change the shape of our array into, I hope there's something like this. So let me put a bracket. I hope something like this. I'm not so sure if we are totally correct. Then after, x is equal to np, which is numpy. I had my teacher use it to call numpy. I don't know which is right pronunciation, but I think it's numpy. Wrong. So np dot array, then bracket, I pass x, then data type is equal to np dot int 64, right? Want array to be of integer 64 as age and the gender was of data type integer 64. I hope we are good to go. So the next thing we can do is to make a prediction, right? So here I can say results is equal to model.predict, right? Model.predict, I path x, right? Then I want to print the results, which is results. I want to see the result of prediction. Then I put 0. So what I can do here is just see copying and pasting. As a big time, I'm a big fan of copying and pasting. I like it. So results is equal to results. Then after, what I need to do here is render return. Is it return render or render return? I'm not a Django developer, but I think it is return render. Return render, put a bracket, request. Then here what I can do is to specify the template name, which is homemusic.html. But not only that, I want to path the context here. And what I can do here, I can do something like this, results, then results, something like that. I hope that is okay with you. I hope you are with me and no one is lagging behind, right? And I can't slow down the process. So here I can type answer. So let me copy this. I'm a big fan of copying and pasting. So I paste it here. Then I remove context. Then I save. So what I can do here, let me increase the fonts, right? Let me increase the fonts so as you can see clear, you can get a clear picture, right? So let me copy this, make a prediction. As I told you that this function will be for performing prediction for the first if, but else it will be for rendering a HTML page. So I go in urls.py, then here it's not home music. I want to replace with the function, right? Home music function was just for rendering home underscore music.html, but now I've created a masterpiece function which do both function. I mean, for making prediction and rendering HTML pages. So I control S to save the changes, then I go to the browser to see what's happening. So I want to refresh. Okay, so let me try to make a prediction. Let's say, let me type my age. I'm 24, right? And I'm male. So once I click predict, oops, SUR has no attribute predict. What's happening? Model.predict. Let me come here and see what is wrong. Okay. I get. I know what's happening. So here, what I need to do here is I can say model is equal to joblib.load. Then I pass the name of the model. I click Ctrl S, then I'm going back to the browser, refresh and make the prediction once again. So let me refresh the browser, okay, to see the results. Okay. Let me refresh the browser. Now you can see your preference music is hip hop, right? It's true. I'm 24 years old and I like hip hop, but never scared to call me sir. Keep on calling me sir. I really appreciate the respect you give to me, right? So let me send you to the home underscore music.html and I show you and explain for you why this message appears, right? So here what I can say, you can see here, this is the context. So in results contain the answer of prediction, which means it carries your music preference. So if you like hip hop, you like R&B, you like classical, so results carry that answer, right? As I like hip hop, so in results the value carried is hip hop, so I put it in dictionary, then I pass it in HTML. So coming in HTML here, you can see I can say if results is equal to 0, your preference is music. Else if results is equal to 1, your preference music is jazz. Else if results is equal to 2, your preference music is equal to classical. 3, dance. 4, auto I can't pronounce it, this kind of music. But where does these values come from? 0, 1, 2, 3, 4. Let me return you to the Jupyter notebook and show you where did we get 0, 1, 2, 3, 4 representing different types of music. Here you can see before we repress we repress column generally with number. You can see hip hop stand for 0, jazz will stand for 1, classical stand for 2. So for my case, as I like hip hop, so the answer of prediction was 0, right? So when I come in HTML template, I just say if music preference is equal to 0, Mr. Mo take up like hip hop. If result is equal to 1, then Mr. Mo take up like jazz. If results is equal to 3, then Mr. Mo take like dance music. I hope you get the clear picture of how you can start with machine learning from Jupyter notebook and ending on deploying your model you created on Django, which is Python web framework. I'm not so sure if you have any question, but if you have any question, comment below. I'll be there for help, right? So If you get an error, if you just stumble, call me, I'll help you. But I just want to tell you that this is an end of our beautiful tutorial on making personal music preference according to age and gender, right? I'll upload the Jupyter notebook dataset and this Django project to my GitHub account. So make sure you check the video, check out below video description. You will see a link where you can download the source code. I hope you had awesome tutorial. Thanks for your Lois time. Stay with more tech. Goodbye and see you in the next tutorials.
Don't forget to subscribe and turn on notification.